Welcome back to Unit 2, Polynomials. This time we're going to deal with Section 5.5 and Chapter 5 of Unit 2. We are going to do some division of polynomials. The first part of this lesson is dividing polynomials using long division. So that's our goal for today. Use long division to divide two polynomials. So here are two polynomials we're going to divide. When we divide these, think about this similar to what you did with long division once upon a time in elementary school. If I wanted to do 250 divided by 11 using long division, I would set it up like this. And I would say, okay, 11 goes into 25 how many times? Well, 11 goes into 25 two times. So 11 times 11 times 2 is 22. And then I would have subtracted. And I would get 25 minus 22 is 3. I still have a number out here, so I bring that 0 down. I get 30. 11 goes into 30 two times again. 22. 30 minus 22 is 8. There's nothing else to bring down. We later learned we could put a decimal and bring a 0 down. But when we first learned it, we said 22 remainder 8. And then eventually we wrote it as a mixed number, 22 and 8 elevenths. Okay? But that's the idea. That was the idea of long division. See how many times that number can go into the result. Put that value in, that product in, subtract, and then you continue until you are out of numbers inside of the division symbol. We're going to do a similar thing here with long division. With long division, we have the division box. You're going to put the left-hand polynomial, in this case 2x to the 4th plus x to the 3rd plus 0x squared plus x minus 1. You're saying there's no 0x squared up there. You have to hit all the terms. So 0x squared really, it's omitted because 0x squared is 0. We don't need to do plus 0x squared normally for writing it, but if we're going to do long division, we need that 0x squared term accounted for. So, on the outside is going to go to the polynomial. Same thing, if we skipped any terms in this polynomial we're dividing by, we would put a 0x or a 0x squared or whatever the case is, but this has x squared, x, and a constant. All terms are accounted for. So, how do we start it? Well, we take this first term here, 2x to the 4th, and whatever the far left term is on what you're dividing by, the divisor, and we say, okay, 2x to the 4th divided by x squared is what? Well, 2 divided by 1, I mean, there's really a 1 there, is 2. And x to the 4th divided by x squared is x squared. Or 2x squared times x squared is 2x to the 4th. However you want to think about it. Now, since this is an x squared, not an x cubed, we're going to slide it down on top of our 0x squared terms. That's how your book keeps them constant that way, or that's how they line things up. So I want to be along the same lines as your book. I want to be consistent, I guess, with your book. So what do we do now? We're not done. We weren't done the first time there. What we did is we took this term, we put it up on the ups or on the top, and we multiplied it by what was on the outside. So we're going to do the same thing here. We already know that 2x squared times x squared is 2x to the 4th. You better get the same terms to cancel out, or the same terms when we cancel out, they're gone. If you don't get, in this case, 2x to the 4th again, you know you did something incorrect. 2x squared times 2x is 4x cubed, and 2x squared times negative 1 is negative 2x squared. So at this point, what did we do on the previous problem? On the previous problem, we subtracted what was happening in the second step. We're going to do the same thing here. 2x to the 4th minus x to the 4th is gone. X to the 3rd minus 4x to the 3rd is negative 3x to the 3rd. Notice I'm subtracting these values inside. In other words, switching their signs. 0x squared minus a negative 2x squared. Well, that's really adding 2x squared. So 0 plus 2x squared is 2x squared. We're subtracting everything. What people do and get this wrong is they subtract the far left terms, but then they just add vertically instead of subtracting. You have to subtract. So, here we go. Are we done with this? Is this it? We put a remainder. Not yet, because we still have terms out here. We have this x. So we have to bring down a positive x. And the whole thing starts over again. So x squared and 3x to the third. What is negative 3x to the third divided by an x squared going to give us? Well, negative 3 divided by 1 will be a minus 3. X cubed divided by x squared is x. And now we do the same thing here. Negative 3 gets multiplied by all the terms outside. Negative 3 times x to the second is negative 3x to the third. Negative 3x times positive 2x is negative 6x squared. Negative 3x times negative 1 is positive 3x. Subtract these terms. Negative 3x minus a negative 3x squared, those cancel out. 2x squared minus a negative 6x squared would be like adding 6x squared. That's an 8x squared. X squared minus 3x, or excuse me, x minus 3x would be minus 2x. Are we done yet? Nope, there's still one more term to bring down, and then we will be done. We have to bring down that negative 1. We restart the whole problem once again. So 8x squared divided by x squared. 8 divided by 1 is a positive 8. X squared divided by x squared, they cancel out. So we just get a number out there. 8 times x squared is 8x squared. We distribute again. 8x squared. 8 times 2x is 16x. 8 times negative 1 is negative 8. We are going to subtract these terms. We get the x squared to cancel. Negative 2 minus 16 is negative 18x. Negative 1 minus negative 8 would be plusing 8 or a positive 7. There is nothing left for us to divide by up here, so we are done. But how do we write our answer? Well, the way we write our answer is we take what's up here above the dividing symbol. On the top, when we say 2x to the third, 2 squared, excuse me, the second power, minus 3x plus 8, plus this result right here is our remainder, 18x, negative 18x plus 7, divided by, well, what did we divide by the whole way through? We divided by x squared plus 2x minus 1. So divided by x squared plus 2x minus 1. So this is how we would write our answers. The whole thing down here for you, a separation. This is our answer. So that is long division, how we would use it to divide two polynomials. So we're going to do obviously more examples tomorrow in class, but that's the idea of it. You may have to rewind that a couple times and try it on your own. See if, write the problem down, see if you can get it on your own, and then play through the video again and to check up how you get the answer, practice it, make sure you have the notes down, and we will see you in class tomorrow.